that the
Yeah, because that has CSU.
well,
Also,
Fort Collins, I think I read once that Fort Collins has like the largest number of restaurants per person per capita, of
New York.
so yeah, we love our restaurants. I guess I mean that's just what I heard, but I don't know if that's true or not. But it's a lot of restaurants, and so it stands to reason that food would be a little expensive just because of that. So um
We wait.
no, let's get started now. Let's go ahead and we'll be trendsetters here. So the things to focus on here would be practice test 4 and practice test 5. And let me first of all pull this up here and ask if we've got questions on this. Yeah, I was planning on doing that. Actually, yeah, we can do that. Okay. Okay. All right. See if you can pull up those specific problems here. Let's tackle that head on. Well, surely you tried some and got the wrong answer. And so let's find those problems. Let's focus on those. Yeah.
From spreadsheet, use my phone to do all the
Yeah.
writing the questions. I can't use on the spreadsheet. My computer.
Okay, we can do that. Yeah. Yeah.
Plus, I don't feel like getting a 0 grade is was cheating. So
I know.
my CEO would not be too happy about that.
Yeah. I mean, the reason why I hesitated is that I know of a situation in which a student used photomath during a test, which is an app on your phone that literally you take a picture of an equation and it's like ChatGPT for math. It basically takes you, oh, here's how you solve this and blah, 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 and it takes you through the whole thing there. I don't think that you do that. And the fact that we're really a small group in here and we're really informal, I think it's fine. So yeah, go ahead and do that here. Any questions on this one here? I'm looking at standard deviation of the probability distribution. Ooh, what's our formula for this? 4, yeah.
Can you show us 11?
This goes to 11. Yeah, sounds good. Hey. National Emergency Number Association set a national standard for answering calls. 95% of 911 calls should be answered within 20 seconds. In Portland, Oregon, the reality is much different. Last month, just 45% of 911 callers got an answer within 20 seconds. A random sample of 25 emergency 911 calls in Portland was taken over a month. Let X be the number of 911 calls that are answered in Portland within 20 seconds. Use a binomial distribution. Hey, this has Sierra written all over it. Yeah, this is an example of the kinds of problem that you would be wanting to look at here. This is in practice test 4, it's question 11. So this is an instance in which we're given a probability as well as a number of trials. Whoops. So yeah, so this is a binomial distribution. And there are two parameters to a binomial distribution. There's n and there's p. And this is reflected on your spreadsheet where there are two little green boxes to put in your answers there. So what's n for this here? Yeah, because there's 25 calls, emergency calls that are made. And what's the thing we're looking at about those calls? What's considered success? If you're not sure, take your time, read the question. Math brain turned off. What's considered a success? for one of those 25 emergency calls there? Yeah, Noah?
To be answered within 20 seconds.
To be answered within 20 seconds here. And what's the probability for Portland that that's going to happen?
0.45.
0.45, I think it was, right? Yeah. So in our spreadsheet, we're going to put in this for N, we're going to put in this for P, and there's a bunch of questions that are going to be asked about this here. Okay, so we'll take it from there here. Let me turn this off here, and we'll switch to the spreadsheet. This over here. And we'll pull up our binomial spreadsheet. You can do this with a calculator if you don't have this completed yet, but you have to know the formulas to be able to do it. So 25 calls and 0.45. Okay, so once we have that, we've got this distribution here to the right. It's possible that none of those calls get answered within 20 seconds. It's possible that all of them, if we go farther to the right here, if we go all the way to the right here, it's possible that all of them got answered within 20 seconds here. But what's the most likely scenario?
11.
Yeah, it looks like about 11 or so.
11.25.
Yeah, so Noah is taking a look at, yeah, you've got the mean here. I was also looking at the mode because the tallest bar here is over 11. Yeah, so we've got variance and standard deviation here as well, and those things are being asked for here and here. How do I find out what the probability is that exactly 12 of them are answered within 20 seconds? Yeah, so it's whatever the height of bar 12 is here. We can also see that
Oh,
these bars here are these numbers here.
oh, okay.
So
So we just have to look on the 12.
good, yeah, it's just the distribution, here. So yeah, what's the answer to this one?
The 0.15.
Yep. So yeah, that's that. Yep. Now, how do I answer P is P probability that X is less than 13, that less than 13 of those calls get answered within 20 seconds. Now we're going to switch from the distribution itself to the cumulative distribution where we're adding things up, remember? And let's see, we want this to go up to what, but not get bigger than what?
Uh,
Less? Well, do we want to go up to 13 though?
I think
Do we
12.
want to include
I think until 12.
until 12, but not up to 13 because it has to be less than 13. So we want to stop at 12. So yeah, this is the cumulative distribution value here for 12. So it should be 0.69 something.
Mm.
And no, you don't have to get all those digits in there, like just, get it to 4 decimal
Oh.
places, you're fine. With that in mind, how do I figure this out?
X greater than 8. So not
Greater-
including 8, starting from 9.
Starting at 9. But is this the answer?
I think we should add everything after 9,
Well, that's what that is, right?
I guess. Says
But
greater than
let's
8.
but X is greater than 8. What things are being included in that? X is greater than 8. 8 is not included, but yeah, so 9, 10, 11, 12, 13. So that sum is not reflected here at all, is it? Right? So if I that's got a bunch of things here. So yeah,
Yes.
greater than 8 here, that would be all of these, wouldn't it? 9 and
290.
following, right? Whoops, that was not good. Right.
So we
Right.
we just add them, right? But
So we're adding all of these together. Now we could add all of them together manually, or we could say what are these added up to?
And then minus.
And then subtract that from 1. Like, how can we figure out what these add up to? That's this. Right?
I got confused now.
What is that number? How do we get the 133? That's the cumulative, right?
Oh.
That's adding all of them up
Until the 8.
until the 8 and including the 8.
So we can subtract that number from 1.
Exactly. That'll tell us. Yeah. So this one adds up all of these numbers together here to get our cumulative value.
Okay. I did.
Yep. So that's the probability that it's 8 or below. The probability that it's 8 or below. So what's the probability that it's above 8? What's 1 minus that? Does that make sense? Yeah. Yeah. So we'd subtract 0.133, yeah, from 1, and we would get, oh, gotta turn this off here. Following this, Annette? Okay. Just let me know if you've got a question. Okay. So it should be like 8. Yeah. That's right. What's the difference between E and F?
I think if we should include 8.
Yeah. For F, we should include 8. So that's the probability that it's 8 or 9 or 10 or 11 or 12 or so on. So that includes 8. So which ones are we not including?
0 to 7.
0 to 7. That's a little different. 0 to 7. So help me out with the 14. Yeah, we're not on that problem. We're on F. Yeah. So in this case, we're not subtracting this. We're not subtracting this from 1. We're subtracting this from 1. Because here, the ones that are not included are just going from 0 to 7, not 0 to 8. So it's always this question of what's in the club and what's not in the club. Okay, so this will be 0.93 something. Yeah. Okay, so now let's get to Sierra's question. How do I figure out what's in between 9 and 14, including 9 and including 14? So the ones that are in the club are 9, 10, 11, 12, 13, and 14. You're doing fine. So yeah, the ones that are included here are 9, 10, 11, 12, 13, 14. That's how I'm seeing it. Would you agree? Yeah. Okay. So, right. Now, if it was 9, if this were a less than rather than a less than or equal to, then I don't include 9, do I? Right. No.
So if this is less than 9.
Careful. This is not saying less than 9. This is saying 9 is less than X.
Okay. So if it said 9 is less than X, you don't include any
Below 9.
below 9?
No, because it's basically, think of it this way. This is our way of saying that it's in between two things. So 9 is less than everything in the group,
Okay.
and everything in the group is less than this. See, so we don't include stuff that's below 9. And we don't include stuff that's above 8. So this is the, yes.
13.
Yep.
If it said less than 8.
If these were both less thans, then would we include 9? Correct, we would not.
But you would also not include
14, correct. That was my next question. So very good. That's right. So we would only include 10, 11, 12, and 13, right? See the difference there? So once you know that, I mean, You could, if you wanted to, just add up all these numbers together here to get the answer.
Like I,
Yeah. Oh, you're right. You can do that. Right. Exactly. Or if you want to get fancy schmancy, you can take this cumulative and subtract off this cumulative. Get the same answer. Yeah. So that's how you do something like that. We were also taking a look. Sally and I were looking at the Lionel Messi problem once again from our PowerPoint. And this one, I like this one because this really brings home what this binomial distribution really is. This is a binomial experiment here that we're running. We're treating it that way. What's n and what's p? How many trials? And what's the probability of success? N and p.
is N 60.3.
N is the number of trials, the number of chances that he gets. Yeah, 3. And what's 60.32%? What's that?
That the
Probability of success. Yeah, right? So, okay, so this is the hard part here. Just let's read this with your math brain turned off. What's going on here? What's this thing talking about? Let's translate this into your own words. Yeah. That must have felt good. How often does Messi, how do you pronounce it? Messi or Messier?
Messi.
Messi. How often does he get is he successful with a shot on goal? 60% of the time. That's probability of success, right? With each trial. And how many chances is he getting? 3.
Three.
Okay. So let's go to our spreadsheet. Yeah, Todd, did you have a question? Okay. So let's see, he's got 3 trials and it's 60.31%. Is that right?
62. Yes.
60.032. Thank you.
2.
60.
Mhm.
Thank you. Okay. So I've got this incorrectly here now. And so here's what your spreadsheet's telling you here. First of all, I need to change that title, don't I?
That's the binomial
Can you-
spreadsheet, right?
Can you show me?
Here, let me zoom into the spot here. I just put in these 2 numbers. So there's my N and my P. And if I put those in, your spreadsheet's telling you, okay, there's a possibility that Messi doesn't make any of the shots that he makes. Has a bad night. There's a possibility he makes one of the 3. Doesn't tell you which one, but there's a possibility he's going to make one of the 3. There's a possibility he'll make 2 out of the 3, and there's a possibility he's going to make all 3 of them. Right? What's the most likely scenario?
Thanks.
Yeah, the tallest bar is 2. And that kind of makes sense. 60% of the time, that's about 2/3. Yeah, so that kind of makes sense. Okay, so, but what's the probability that he makes it one time? 28%. What's the probability he's going to have a bad night, not make any? 6%, 6.2%, yeah. So not very likely. There's a 22% chance about that he's going to make all three. Have a really good night. Okay. By the way, not that I'm suggesting this, but do you think that people who bet on sports games use things like this to try and evaluate probabilities as they're approaching games and stuff like yeah, this is kind of stuff they're doing all the time.
Thinking.
Yeah. Yeah, that's not the good way to do it. Yeah. What was the thing I was gonna mention? This. And keep in mind, we're treating this as a binomial experiment. So one of the things we're ignoring is the possibility that he's missed twice, and so now he's corked off and just kind of and so his probability of making the third time maybe goes down because he's gotten into his head or something. We're just assuming that there's no psychological effects of missing it twice or getting two in and thinking tonight, and so your next one might go in a little bit more likely or something. We're ignoring all that stuff. So keep in mind, we're always dealing with abstractions. We're always dealing with an idealization of reality. Anyway, what else? Back to the practice tests here. Anything on practice test 4? By the way, how would you do question 9?
The same thing?
Yes, you're literally just copying the numbers out of your
Same
spreadsheet.
thing.
Just going down the list there.
We have
Yeah.
the N and P, so
Yeah,
we
you've
just have
got
the same thing.
exactly same idea there. So nice and easy when you've got your spreadsheet here. Some of this early stuff though, before we get into binomial distribution, want to make sure you know that too here. Um, you've got a random variable.
So do we just add everything?
Find the expected value. How do I find that? A lot of people forget this.
I think
It's important.
it's
It's good that we're going over it.
same thing like finding mean.
You can read it on the spreadsheet and then multiply the 0.2 by the 6. And then 0.23 by.
That's a frequency table. This is a probability distribution. Be careful. So there's a 20% chance you'll get a score of a 6. There's a 23% chance you'll get a score of a 7, and so on and so forth here. This is our formula.
So kind of mean, right?
Like.
And you do add them down. So I suppose the math is the same, but it's important to understand that it's a different situation here. So yeah, we create another column here, XPX, multiply these things out. This will be 1.2 as an example. And once we've got all those, we add them up, and that's our mean. There. Okay, so there's that. What's our formula? I know that the next one below asked for a standard deviation. So our formula for variance is this. And don't forget this second part here. A lot of people forget that second part. Yeah. That's your formula for variance. Make sure that's in your test taking resource. And how do I get standard deviation once I've got variance? What's it? What is it? I've got variance. How do I find standard deviation?
Square.
Square root. Good. Yes. Okay, so that's chapter 4. Sehr gut. Okay, so let's take a look at chapter 5 here. That was the uniform distribution and continuous probability distributions, all that kind of stuff. All that good stuff. Okay, now question one, you guys already know this stuff. Who is this? Is the second one here left skewed or right skewed? Left skewed. Yes, great. Yeah. Also negatively skewed. Yeah. How would we say that? Sierra.
It's, I can't. see it.
Sorry.
It's asking for the round shaped area that represents, and it's between 6 and 7.
Uh-huh.
So I said P 6.
Yep.
Less than X, less than 7.
I picked on you because that's the notation that we were talking about before. This is the way we say that it's in between something, 6 and 7. Yeah.
I was a little confused when I saw the question or something.
Yeah. Yeah.
Can you explain this one a little bit? The next one, the following.
Oh, next one
this
here?
one, yeah.
Yeah. Ooh, tell me about this distribution. Symmetric, left skewed, or right skewed?
Right skewed?
Right skewed. Okay. First of all, if we're looking at mean, median, and mode, which is A? What's this? Remember, what is mode again?
The most repeated.
Most repeated. So where is that? A, B, or C? Yeah,
A.
so it's A. So that A has got to be the mode, right?
Um,
And when you've got a skewed distribution, does that affect the mean more? Does that push the mean out more? Or does that push out the median more? The mean out, yeah. So which one is
it is right.
So which one's farthest to the right? The mean, yeah. And the one in between the two will be median. Yeah. So it's mode, median, mean as you're going left to right, and that gets reversed when it's left skewed. But the big thing here is, do you understand the logic behind that?
So if it is left, it's opposite, right?
Yeah.
Okay.
Yeah. Area equals what? Probability, yeah. So the probability that X is greater than 1.08 or is less than 0.36. Ooh, how many rectangles do we have now? I'm seeing 2, yeah. So 1.08 is right here. And it's greater than that, okay. And ooh, less than 0.36. 0.36 would be right there, and I've got that. So I've got two rectangles to find the areas of and to add up those areas. What's the height of this rectangle?
1/2.
1/2. How'd you find that?
Like because the X is 2, so we have
Yeah,
to do it 1/2.
this whole distance is 2. The area of this whole thing has to be 1, so this has to be 1/2. Ooh, Ta, you okay? Which measurement? Oh, right. So we have to figure that out. Exactly right. That's why, yeah. So that's 1/2. So now let's focus on this first rectangle here, the smaller one. It's got a height of 1/2 and it's got a width of what?
0.36.
0.36. Okay, so we can find the area of that rectangle. The other one also has a height of 1/2. And what's its width?
1.08.
Is it really though?
Well, I think we have to subtract from 2.
I agree. Yeah, so 2 minus
1.
1.08. Yeah. So that's our width. So width times height, we get the area there. And so, or these things are mutually exclusive, we'd add them up.
Minus 1. From 1. We subtract from 1 or just add
Well, you tell me.
I would say if we find each area, we can add them.
Yep. And then that would be our probability that either one of these are true. And if we subtract it from 1, we would find out what this is. That's not what they're asking. Yeah. Making sense? Making sense. Okay. That was actually a harder one. Usually it's just one rectangle instead of 2 rectangles you have to add together. Yeah, like this one here. Ooh, how would I draw a picture of this distribution here?
The distance from 33 to 57.
Yeah, it's a uniform distribution between 43 and 57. It stops there and ends there. So what's the width of this rectangle? Yeah, what is that?
I think we have to subtract 57
Yeah.
from 43.
Yeah, which is what Sierra did, and she got 14.
Mhm.
Okay. If the width is 14, the area's got to be 1. So what's this height got to be?
1 over 14
1 over 14. Because 1 over 14 times 14 is
is
1. Okay. And we want the probability that it's that it's in between 51.2 and 54.9. Okay, so this is the area of our rectangle. If we find the area of this, we have the probability. The height is 1/14th, and the width is,
Mm,
what do you think of that? What's the width of that thing?
54.9 minus 51.2.
Yeah, right. So 3.7, yeah. So yeah, that would give us our,
When you graph it, it make a lot sense and easier, but when you read the question, it's harder.
that's why I tell everybody to draw a picture. When you draw it out, you figure it out. Yeah. Let me clear.
Answer for it?
Yeah, whatever 3.7 divided by 14 is. Somebody get that.
I got 0.264.
And the math is happy. To be asking yourself the question, would I know what to do if I were given a problem like this? And I had to solve it again. I had to do it again. Would I know what to do?
Graph.
Yeah. Well, yeah, draw a picture.
Yeah, draw a
Graph.
picture,
We'll
yeah.
say graph. Yeah. Yeah. Case in point. Ooh, this is a hard one. This is a good one. What does the distribution look like here for this one here? Noah, what do you think?
I'm reading the question on my end.
Yeah, very, very good. Very good.
What's the question again?
Yeah. What does this distribution look like?
That's a uniform distribution.
I agree. So if I were to draw it, where does it start and where does it end?
Starts at 10.82
I
and
agree.
it ends at 26.17.
Okay, so it's some kind of uniform height. I don't know what it is. What's the width of this rectangle?
Minus 26.17 minus 10.82.
Trying to do that in my head. Is that right?
15, yeah, 15.8.
Okay, so 15.35. So yeah, the numbers are ugly, but what's the height of that rectangle?
1 over
1 over 15.35. Yeah, which is hard to visualize, but you can figure it out what it is on your calculator. Now, interesting question here. Find the third quartile. So what does it mean, third quartile?
75%.
Yeah. So is that going to be on the left side or the right side?
Right?
Yeah. In what way? Once I slice it, how much of the area should be to my left?
75.
75%. So see, if I divide this in half, it would be like right here, right?
Mhm.
And so 3/4 would be like right here, wouldn't it? With all of this being 75%. That's what I'm thinking. Does that make sense?
Yeah.
Yeah. So what I've got to do is figure out where is this location here? What is that? on the x-axis. Well, it's 75% of this distance from here, isn't it? 75% of that distance. So what is 75% of this distance here? How do I find that out?
Times
75% of something.
So then 75 over 100.
Yeah. Yeah. And multiply it as a decimal, 0.75. What do I get there?
11.51
That's
times.
about right. 0.51. Okay. So what that tells me is that this distance right in here needs to be 11.51. Okay. But is that the answer? Is 11.51 our answer?
No,
No. Okay. What is our answer?
11.51 times 1 over 15.35.
Well, no.
No.
No, I'm making it too hard.
Um,
It's this distance here is 11.51, but are we starting at 0?
oh, okay.
If we did, that'll give us this distance. But that's that's not really getting us closer.
That's tricky.
Yeah. So here's the thing I need you to see. We're starting here at 10.82, aren't we? And we're going another 11.51. So where does that leave us? Where does that take us? What's that?
To the third.
Yep. So how do I find that? We started at 10.82. Let's subtract.
Yeah.
That's what I'm thinking.
Why we add them?
To add them together.
Well, let me ask you a question. If I took this number and added this number, what would I get? I'd get way over here, wouldn't I?
Yeah.
Right?
Uh-huh.
And so in the same way, if I take this number and I add this number, that should get me here. Right?
Okay.
Yeah. So yeah, 10.82, 11.51. Tell me if I'm right. Does that? Yeah,
Yeah.
okay, very good. So $22.33 should be our answer here. So interpret that for me. What is that? What do we just find?
The 75% of the rectangle.
75% of the time, the value of the stock is
22.3.
75% of the time, it's exactly that.
No, below.
Below. Very good. 75% of the time, it's below that value. Very good. Okay. So you can see how a picture helps.
That's true.
Yeah, makes it a lot more easy. Yeah. All right. Anything else here? Anything flying out to anybody or whatever? Ooh, this bottom one here. General rule of thumb that within 1, 2, or 3 standard deviations of the mean, we've got 68%, 95%, and 99.7%. That was in a PowerPoint. So we sketched that distribution here. The widget weights have a mean of 64 ounces and a standard deviation of 8. Okay, so 68% of the widget weights lie between what and what? Tal, what do you think? Hmm? Yeah, 68% of the widget weights. So what do we do? What are we dealing with here? How many standard deviations?
There's standard deviation. Or am I just reading that?
Yeah, so that previous sentence used the general rule of thumb that within 1, 2, and 3 standard deviations of the mean lie 68%, 95%, 99.7% of the data. Okay. So 68% of the data is within how many standard deviations? Just one. Okay. So on this normal distribution here with a mean of 64 and a standard deviation of 8, what are the endpoints of that? If I subtract the standard deviation and add a standard deviation to the mean, what does that send me? Are we not seeing the picture I'm drawing? Okay, so I'm here at 64. Each one of these is a standard deviation of 8. So where am I now?
72,
72. And if I go in this direction,
47.
40,
Let me see. I think 52. I don't know. Let me.
56.
Okay.
Okay. So when we say that 68% of the widgets, 68% of everything lies within one standard deviation, that means that 68% of these widget weights lie between 56
Oh,
and 72. What percent of the widget weights lie between 40 and 72? Oh, probably we should, okay, figure this out here. If I go down another 8, what do I get?
40.
40,
2.
nope.
Um,
No?
48.
48? And if I go down another 8, what do I get?
40.
40? Okay,
Oh,
good.
okay.
If I go up another 8 here, what do I get?
80.
80. And again,
88.
88. Okay. So 8, 8. Okay, so between 40, and 72 ounces. Okay, so that's a little hard. So it's 3 standard deviations in this direction, but only 1 standard deviation in this direction here. Okay, so if it's 68%, if I go 1 standard deviation in both directions, how much is it just going in one direction? Not 68, but 34. Okay, so this in here, it's half that, 34%. Got the other 34% on the other side for a total of 68. And then let's see here. This is 3 standard deviations. So I want to cut this in half as well here. What's that going to be? Is that it? Is that right?
Why you're cutting that percent, like the 99%?
Yeah, because we're only considering one side.
Oh,
If we were doing both sides, it'd be 99.7%, wouldn't it? But we're only going out 3 standard deviations on one side here.
okay.
Okay, so the okay says I'll take that, but I'm not sure I understand.
So do we the 99.7, do we divide it by 3 or by where do you get the 49.85?
Just cut it in half
Oh, okay.
because we're just dealing with one side.
Oh, okay.
So over here on this part here, it's 49.85%. Over here, I've got 34%. What do I do?
Can we add them?
Add them together. Yeah. What do I get? 83.85%. Okay. What percent of the widget weights lie above 48 ounces? Ooh, above 48. Wow. So that's all of these. Okay. Okay, so 2 standard deviations from the mean here on one side.
Mhm.
That's 95% divided by 2, since I'm just considering one side here. So that's going to be 47.5%. Is that right? 95% cut in half. And then, all of this over here, including everything way beyond here. How much of the area is on this side of the normal distribution? Total. 50. Yeah. So those two things we add together. Yeah, yeah. But do you understand why? Okay, so that's the real question. Yeah. So we're considering all of this stuff here. It was saying above 48 ounces. So that starts here and shades in everything to the right here. Well, what is that? Well, once we get up to the middle and we shade everything after that, that's half the distribution. So that's 50%. So we just have to really figure out what this part is here. That's, yeah, 95% cut in half. Yeah. So it's very visual, this stuff, isn't it? Yeah. All right. Any questions? All right. I'll hand them out. I will pause the video here until the test is done. We'll come back. We'll do a little bit more with normal distributions.
Here we go.
An hour.
Any questions?
You can
Well-
see. Yeah, I think it's, yeah. Sorry. Yeah, everything that you can use is listed at the top there. So yeah, you can use Desmos, you can use your spreadsheet, all that stuff. Missing. So many people missing today.
I use an empty paper to do.
reminder to put these things into your taking resource there. Just if you didn't put those things in, you've got some easy ways to calculate mean, variance, and standard deviation for binomial and uniform distributions.
Is it supposed to have like is this a yes or no? Is that what
Yeah,
I'm
it's a
asking?
yes or no.
Oh, okay.
Yeah. For question 4, part A, it's just a yes or no question. To say yes or no. Yeah.
First,
Nearest hundredth. 2 decimal places. Yeah. About 10 minutes left. About 5 minutes left. minute left. Would please hand in your tests here at this point. Thank you, thank you. Max. Well,
Oh, yeah, I was just about to ask you for it. Thank you.
Yeah.
Um,
There you go, Sally. Oh, no. Is that the right one? Yeah, is that you? Oh, no. Ooh, same thing. Oh, and name. There. Got both of yours. Yeah, there you go. Lucy Smith here. Us here. That's why I don't have that it. One, two, three, four. We've got a little bit more that we want to cover today. That's fine. Oh, your name?
Didn't speak out or stuck a lot of my little joke here.
I did. I like it.
So you don't check this one is mistake.
Yeah, if you don't see points, then yeah, it was incorrect. I'm trying to actually get a little bit better and saying no, that's being a little more
Here.
explicit.
Was it 5?
Yeah, it's worth 5 points. So
Oh, I can see.
yeah. Yeah, very good. So you can look those over here. I want to yeah, I want to see about bringing everybody back here. I realize I just handed back last test as well. I understand a desire to look over that. But let's also take a look at a few problems here that will basically finish up chapter 6 for all of us here. We got this present. All righty, so let's take a look at this problem here. This is a pediatrics problem. It's a continuation of a problem that we did last time, started last time. And it's a good example of how when we are working with these kinds of problems here, we're actually dealing not just with one normal distribution, but with two normal distributions. We're drawing out two normal distributions here for each one of these problems. And in fact, what's the first normal distribution that we're plotting out here? Tell me about it. What's its mean? Mm-hmm. So it's the average height of 3-year-old female patients. And what's the standard deviation here? 3.17. Okay, very good. So that's our distribution of X values. That's our distribution of the raw data. In order to take a look at in finding the 20th percentile, that is a horrible bell curve I just drew there, but whatever. We're going to deal primarily actually with the Z distribution here, which is always has a mean of 0 and a standard deviation of 1 here. Now it's hard to figure out what the 20th percentile would be for this distribution here. We've got a chance with this distribution here, but to do that, what does 20th percentile mean? We looked at this earlier with the uniform distribution. Is the 20th percentile going to be on the right-hand side or the left-hand side of this thing?
Left.
Yeah, I agree. And in particular, it's going to be on the left-hand side with this area being how much? 20%, yeah. So this will be, this area here will be 0.2. So the question is, what is the Z value for which 20% of the area is to the left? If only there was some function that we had at our disposal to be able to answer that question of what's the Z value for which the probability of something below that being equal to 0.2. A spreadsheet function of some kind that students made use of. Are we inputting a Z value or are we trying to get out a Z value?
Yeah.
Get out a Z value. Okay, so that'll give you a hint as to whether or not we're working on the top or working on the bottom. What do we get for a Z value there? So, yeah. So what's our Z value here?
0.84.
Is it positive or negative? Okay, good. 0.8416. Okay, are we all comfortable with how we got that? I know that look. So you're putting in 0.2 into the lower, the P score for your Z value. I'm getting a Z value out of that.
Is this question in our textbook?
Yeah, it should be slide 20.
Is that 6.1?
6.2.
Okay.
Yeah. So yeah, this is the part of our spreadsheet where you see P score and then there's a Z score. You put in 0.2 over here and you should get out negative 0.8416. See if you can. Yeah, you didn't have it in?
No.
Okay. Okay.
It's on
Check.
18, sorry.
Oh, okay.
All right, so we've got this. So we have our Z score here. We've got to figure out where this lines up on our distribution of X values. That's the actual heights that these 3-year-old girls have here. So how do I convert from a Z value to an X value? If only there was a formula somewhere on our summary sheet that could give us that.
X minus mu, I don't know.
Careful, are we trying to get a Z value or trying to get an X value?
Z value?
We have a Z value. It's right there.
Oh, okay.
So-
So X equals to
Yeah,
mu plus standard deviation in Z.
there it is. Good. Mu plus sigma Z. Alrighty here. So what's mu? 38.72. Good, Derek. And what's sigma? 3.17. And what's our Z value that we just calculated? Yeah, negative 0.84. 0.16. So you can find out what that X value is. Yeah, what are we getting there?
36.05.
36.05. Okay, interpret that for me, please. Tell, what did we just find? Yeah, the 20th percentile for heights of 3-year-old girls is 36.05 feet. And then your friend says, well, what does that mean, 20th percentile? And you say 20% of all
All three.
3-year-old females have a height that is it is below 36.05. Yeah. Alrighty. So yeah, we have this normal distribution. And by the way, you could make use of your handy dandy new spreadsheet pages to where I've got those. Here where you can okay. So we're looking at a one that's got a mean of 38 point, what was it, 72? So I think that's right. Yeah, 38.72 and a standard deviation of 3.17. And for now, let's keep sample size to 1. We'll leave it at that here. Okay, so we're putting in these values here. And go ahead and turn off distributions 2 and 3 by putting in a 0 here for both of these.
Why,
For the
why
sample
we
size.
put 1 on the sample size?
It's just something that we do now.
Okay,
Yeah, next chapter we'll change it to something else here.
okay.
Yeah. And let's see, this is going to be somewhere between, see, the mean here is 38. So I should probably have the x-axis start at maybe 25 and then maybe go to 45. Something like that. Okay, so that frames it kind of nicely. See 25 to 45 there. Maybe I can go a little higher. See, so there's our distribution there of heights of 3-year-old girls. That's our actual normal distribution. And we were trying to figure out what the 20th percentile was of that. We could actually probably get something close to that here. 10th percentile, 25th percentile. Calculates all that for you. And plus, we also have this way of doing it as well. Okay. A researcher for a medical study wants to select people in the middle 60% of the population based on blood pressure. So not too, sort of like in the Goldilocks region, not too high, not too low. The middle 60%. So the middle 60%, who's outside of the middle 60%? How many?
40,
40. So how many are over here and how many are over here?
20.
20 each. Okay. So that's kind of the picture that I have in my head here. See that? The middle 60% means we've got 20% on each side. 20% are too high, 20% are too low. And we're told that the mean systolic blood pressure is that, and the standard deviation is that. Find the upper and lower readings that would qualify people to participate in the study. Okay, so that's something we can do if we're just taking a look at the if we're just taking a look at the standard normal distribution, we just have to find out what's the z value for which 20% of the area is to the left. That's the same thing that we had before here. We actually found that out in the last problem. Once we have that, then we can do the same. We can convert this to values of systolic blood pressure by using our formulas here. This is negative 8.8416. So this is positive 0.8416 because of the symmetry of the normal distribution here. And so we just use a positive version of z here to calculate this. So what did we just find? For people to qualify for the study, their blood pressure has to be between what and what?
113 and
Yeah,
126.
between those values there. That's the middle 60%. Okay, let's skip this. How do we know if we're working with normally distributed data? In the real world, we don't get these nice, perfect little. Turns out if we're pretty close, we can still make the same assumption here. So the three things we look at, does the histogram kind of look normal? Does it look reasonably normal, or is it, kind of all crazy and stuff? Is the distribution reasonably symmetric, or does it have a real strong skew? And is it free of outliers, or does it possess outliers? So first thing, does that look normal? I mean, actually, most statisticians would say, yeah, that's pretty good. That's fine. So we're pretty generous. To see if it's the second question, is it reasonably symmetric or is it significantly skewed? We actually put this into a formula here. This is the Pearson coefficient of skewness. This is the mean. This is the median. We subtract those things off and divide by the standard deviation. If this is bigger than 1 or smaller than -1, we say that it's significantly skewed and not normal. And then lastly, does it have any outliers? We went through a procedure on how to calculate those in chapter 2. So if we've got some data here as an example, we could put this into our spreadsheets and we'd get an average of 127.24. We'd get a median of 143. What does this histogram look like? Does that look normal or does that look pretty messed up? It's pretty messed up. That looks very non-normal. Using these statistics here, I can calculate the Pearson coefficient of skewness here, and I get negative 1.1. That's significantly skewed. So it's less than -1 or greater than 1. It's significantly skewed. And I calculate the number of outliers here. There aren't any data values below 30 or above 228, and so there aren't any outliers. So it passes part 3, but doesn't pass parts 1 and 2. Can we regard this as normal? Yes or no? No. It's just one exercise or two in the homework about that. So that's everything for the normal distribution. Okay, so there is some homework on this that we can that you can feel free to talk to me about.
Is there any way you can push the homework that way we can work on the project?
The project 5? The which one?
So the homework 6.1? If we can,
Yeah, the homework
Yeah.
6.1's due today.
we can do it with the 6.2.
Yeah, I can push 6.1 to Sunday and 6.2 to Tuesday. And then I'll have a practice test. Actually, we already have the practice test sitting there. We are. Yeah, they were kind of cranking them out right now. Okay, so
We
yeah.
almost finished the
Are we-
semester.
It's a practice test for every chapter. Mhm.
I'm like,
Yeah, that's me being random. Sorry. I'll try to be less random. You're being so good. Sorry, Sierra. Okay. Okay, so I'll make a note of that. Sorry about that. I'll
Also, so we possibly have a little bit more time on the next test.
um I'll take a look at that. It's a possibility. Yeah.
But I was,
It's always hard over the summer, just because we're really limited on time.
I was also took time, kept track of the time. He gave us 55 minutes.
I didn't give you the full hour,
We started at 11:05.
and I ended at noon. It's true, I gave you 55 minutes. I would be willing to give you guys the additional 5 minutes, hand them back, and just let y'all do that.
I shouldn't have said anything.
Are we okay with that? Oh, okay, so you'd want to use it for, anybody else want to use 5 minutes on the test? Okay. Okay, so I can talk to you, Sierra, about stuff if it, all right, you want to just take the remaining 5 minutes in the teacher's lounge? That's just across the hallway here. So no, I'm happy to have you with that. All right, everybody, have a great afternoon and weekend and all that kind of stuff. No, thank you. No, I'm glad you raised your hand, man. Nobody's in trouble.
The homework. Yeah.
Yeah, let me push that now. Yeah, yeah.
Have a good day.
Take that down on Saturday then.
Yay, drag and drop editing. This is one of the reasons why I love this thing so much.
So you said you want us to go on the teacher line
That,
for it, or
put
do you
that
want us to
there.
stay here in the test?
I've got to push that here. I've got to start that then. Okay. So let me go back to here. Does that look good for this week? Yeah. Yeah. Sorry?
So do you want us to go in the teacher lounge?
Yeah. Yeah. Great. I mean, just because I don't want you to be disrupted by the talking
Oh.
that Sierra and I are going to do.
Oh, I lock in, so.
Okay, that's fine.
I'm not sure
what
what
time
time
you're
you're doing.
You had a question? Yeah. I heard you wrong. You said you wanted to utilize the 5 minutes, but for something else.
To see if I could answer questions I didn't answer on the test.
Oh, so you do want to work on that?
Yeah, I was asking that because like, it's just like, it feels like a lot of homework assignments pop up out of nowhere. Because I'm like, when I have free time, I go through it and I'm like, okay, there's nothing coming up due, and then like randomly something pops up, I'm like, I don't really have a lot of time to work on this, and that's why I kind of procrastinate.
That's actually wonderful.
Yeah, but it still feels like there's more stuff coming up, like.
Well,
know,
tell you what, I can actually unlock the remaining stuff here that we're going to do, but it's like,
Yeah, it's like.
it's a lot. I agree. It's a lot for everybody. A lot for everybody. Okay. All right. So 5 minutes starting now. About a minute left.